CNC machining is a manufacturing process in which pre-programmed computer software dictates the movement of factory tools and machinery. The process can be used to control a range of complex machinery, from grinders and lathes to mills and routers. With CNC machining, three-dimensional cutting tasks can be accomplished in a single set of prompts. Under CNC machining, machine tools function through numerical control. A computer program is customized for an object, and the machines are programmed with CNC machining language, called G-code, that essentially controls all features, like feed rate, coordination, location, and speeds. With CNC machining, the computer can control exact positioning and velocity. The most frequently used machines in CNC systems include CNC mills, lathes, plasma cutters, and water jet cutters. CNC mills can run on programs comprised of number and letter-based prompts, which guide pieces across various distances. In lathe machines, pieces are cut in a circular direction with indexable tools. With CNC technology, the cuts employed by lathes are carried out with precision and high velocity. Plasma cutters cut material with a plasma torch. The process is foremost applied to metal materials, but can also be employed on other surfaces. In order to produce the speed and heat necessary to cut metal, plasma is generated through a combination of compressed air gas and electrical arcs. Water jet cutters are tools that cut hard materials, such as granite and metal, with high-pressure applications of water. In some cases, the water is mixed with sand or some other strong substance. Factory machine parts are often shaped through this process. There are many advantages to using CNC machining. The process is more precise than manual machining and can be repeated in exactly the same manner over and over again. Because of the precision possible with CNC machining, this process can produce complex shapes that would be almost impossible to achieve with manual machining. CNC machining is used in the production of many complex three-dimensional shapes. It is because of these qualities that CNC machining is used in jobs that need a high level of precision or very repetitive tasks.